Welcome everyone to this our session on putting SUSE Manager proxy in containers. So I will presenting it with Dario. And let's dive first in the agenda. So we will first present the scope of the project, to why we're doing it, what we are talking about, then the challenges and the methodology that we used to reach the goal. Then a small demo to show what has been achieved so far and the future. So that typically means what still needs in front of us to get the whole thing done. So about ourselves, I'm developer at SUSE for 14 years. I worked initially on LibreOffice and then virtualization stack, and for a few years on SUSE Manager.
Yeah, and I'm Dario Leidi. I'm a developer in SUSE Manager since almost 7 years. I've been working a lot on the front end, and now I'm focusing on the containers world and this refactoring we are approaching.
So let's dive a little bit in the scope. As the session title hints that, we will be talking about converting SUSE Manager from the legacy to the container world. Let's see why and what that really means. So, why containers? Not only because it's fun and hype, but there are also business reasons for it. One of the biggest one is to standardize for customers who want to standardize on Kubernetes. So they can leverage the Kubernetes infrastructure and the knowledge, the trained personnel they have to also run SUSE Manager. And then there are also the usual container advantages, like helping to separate concerns between the application and the operating system, helping deployment, so it's easy to deploy everywhere, and scalability, but well, in the future only. It's not because you put an application into containers that it will automatically be scalable. There's some work to be done, and we'll see that it might be quite huge for SUSE Manager. I like to compare SUSE Manager with Stonehenge for multiple reasons. First, SUSE Manager is old. Satellite was the first parent of SUSE Manager, has been launched in 2002, so that means 20 years ago. Depending on how you count, you can consider SUSE Manager as 1 million line of code. You can even consider more if you include documentation and localized strings and so on. And we have about 120 packages in open build service for SUSE Manager without the dependencies. Well, hopefully the comparison stops here. Even if developers have to do some archaeology sometime, SUSE Manager is not that mysterious. But putting Stonehenge to containers is a complex task, and it will be also complex for SUSE Manager.
So let's take a look a little bit closer to the challenge we went through with this part we refactored. So we started with the SUSE Manager proxy, and the reason why we started with this and only with this is that the proxy is something that is a standalone piece of software that works in the environment of a SUSE Manager server setup with clients. So the proxy is something that can live on its own, and it can be refactored without touching other core features, core part of the product. And it is quite small compared to the server. So it is something we can handle. And the main idea of starting with the proxy is not only because of that, but also because we it is a new journey, a new experience, and this is something we want to do for the server. But first, we need to prepare our skills, to prepare our knowledge on this topic, on this work. And the idea of the proxy is to learn while doing it. So during the refactoring and putting the proxy into containers, we can discover limitation and pitfalls and the barriers, and we can discover them in advance before starting the server, which is a beast compared to the proxy. So yeah, we face early what we need to be aware of, and then we can start with the complex part, which is already complex by itself. And last but not least, starting with the proxy is the idea of shipping early. So we can ship the proxy in a containers early before doing the server, and we can get early feedback from users, from even from customers. So the idea is to get the feeling of the users of using containers and where to use it, how to use it, and maybe react and adapt ourselves while doing the server. So in the next slide, we can see closer the the methodology, we how we approached this work. Um, the first thing is understand what are the pieces uh, that makes a proxy. So what are the services? What are the packages? What are the components we need in a proxy when we define a proxy to be complete and working, and and then understanding how to cut into pieces and define what a container should be. So criteria to do this are ideally you start with a service, and once you have a definition of a service, you end up with one container. So you see you have, for instance, a Squid, which is an HTTP cache server, and you get the idea this will be a container, and this will live on its own life in a container. Then you have a couple of other components like SSH, daemon, or salt broker, and this is not only splitting from services to container, but also understanding maybe the component. It's not just a service; it's a service plus something else, like the HTTPD for the traffic, but also with some Python web apps for authentications and so on. So this is another criteria of defining a container and taking the pieces and putting into one container or splitting them. The last point is to cut into containers, in separate containers by technology. That means if something is requiring a, a large amount of Python's libraries, this will be a criteria to cut components and say this will be a container, and what does not need any Python script, any Python libraries will be in another container. Yeah, so that was the first approach. So carving out what is making a proxy a proxy. And as you can see in the picture, there were few components and a couple of connections. So this was not straightforward, but rather simple to understand what are the pieces and how to separate them. So going to the next slide, the another important part of this work was to to change the mindset while developing a piece of software, because normally we are used to think about you have this service or you have these services and you put them on a complete running machine, and what is available in a running machine, it is available for your service, and that means you can use it for free. In the containers world, this is exactly the opposite, and this was the part of changing the mindset, because you need just to understand what your service needs, and then you need to figure out how to get it available, either installing it or configuring it, or or even reaching another, creating another component in container in order to have it. So it's not that if it is available on a machine, you have it. Here you really need to enable every single piece you need in order to run your services. And yeah, so you don't have accesses also to resources, and to so you need to explicitly say, I need this resource, this disk, or this folder. Everything you need to define it, and this is a completely different approach from the normal way. So after this way of thinking, the last part, you end up with containers. Now you need to put them together and make them work together, because they are completely isolated from each other. The the main point here is, now that you have a container, and by definition a container is something that is the stateless and neutral, so you can run it everywhere multiple times if you are in a different environment. It should not have something configured for your specific environment, and then you need something that configures your container once it starts, because a container start and stop, and every living information will die, so it will restart from scratch at the beginning at every restart. So we decided to tailor every container with its own configuration and parameters by creating Python scripts that start at the very initial start of the container. So once the container starts, the first thing is the Python script starts, and it configures the container. It puts config files or change parameters in order to to have the container and the service run as you expect to and as you want to. And this was the tricky part, to get the data from somewhere, get uh, get the configuration, get the script to read the configuration, put in the right place, and then start the service at the end. So yeah, this is how we went through this refactoring, and this is how we worked on carving out services and creating containers for a proxy. Yeah.
So it's now about time to show you what has been done. So before running the demo, you need to clearly understand, if even if Dario hinted it, that there are two parts in here. So first we will create a configuration from the SUSE Manager, so that will get us all the data, and then we'll deploy this configuration onto a machine where we can start containers, and the containers will use this configuration. So let's start a demo. So in the systems menu, you have a proxy configuration item now, and you will be able to fill in the proxy FQDN that you want, the parent FQDN, the squid cache size, for instance, and the proxy email address. And then for SSL, which takes half of the page, you can either use an existing certificate or generate one. Here for the demo case, I will just generate them from the self-signed CA that is on the server and click the generate button. So you will get a zip file containing the configuration files. We'll just upload it on the proxy host. There we have it. And now go into the etc uni proxy folder where we will unzip everything. Since the data in there are sometimes security sensitive, like server key and server SSH keys, better chmod them to read write only for root. Now you just have to start the uni proxybot systemd service, and all the containers are started using podman. So we will now just check that we have at least the HTTPS web page for the proxy that we have. Now you'll see that the proxy is a foreign type, so it's basically a fake node, and you can only handle the proxy operations on it. And now we will bootstrap a KVM machine through the proxy. So now we have it. You see it on the systems list. And now we will run a zipper lr command to ensure that we have the repositories from SUSE Manager that are deployed via the proxy. So you see that we have the repos, and we got them from salt remote commands. So everything works using the containerized proxy.
So let's talk now a little bit about the future. So as you might guess, we will not stop here, of course, as we started saying that this was the initial step, and we started with the proxy for some reasons. So in the next slide, we can see there will be proxy improvements. So what we have done so far is good. It is going to be shipped, but then more improvements will come. So as in the demo you have seen, we start Podman and containers via some systemd services, but then there are also there will be also Helm charts to start them in a different environment, of course, in clusters or in not not via services. So that's something that is in work right now, and it's coming. So this is for sure a big improvement. Another step we already are aware of at the moment. Images are a little bit big, and we are working on slimming them down to get light container images to download faster. Because as we discussed before, you need to enable only what you want in a container. You need to install only what you want, but then you need also to drop something that you might not want to when you install a lot of packages, and maybe something that is not extremely required. So this is something it is worked on by the development team. And the next step in the next slide, exactly, as you remember the simple graph we have seen before, now there is a different picture, and it is not a complete one and not a detailed one. It's just a high level one of how the server looks like. And the idea for this work is to containerize the server. So understanding with the same methodology we have we used for the proxy, we are going to approach the server. So decoupling components a little bit before splitting with the criteria, splitting components to containers, and creating services and enabling what has to be enabled, configure each container, and so on. So this is rather complex and much more work compared to the proxy. But now we are a little bit aware of what we have to do and how to approach this job, this work, and yeah, the main point will be to decouple the code pieces and yeah, for sure creating containers, and in the end we will have a lot of testing, which will be a new type of testing, because testing containers is not the same of testing uh, a whole piece of software, which is the server right now. So one thing to mention, by this refactoring and this move ahead, is that there will be no traditional stacking containers. So and this is an important step. By moving, we can drop some pieces around, and we will drop the traditional stack, because in the container world there will not be any support of that. And yeah, last but not least, we expect feedback as soon as possible. And this was one of the reasons we started with the proxy, to ship something in containers, and have early feedback from users to understand your experience on how we did it and how it works, and the needs, of course. So we will react. Yeah. And with this, we want to thank you for your attention.
Thank you all, and don't hesitate to stop by on the chat to ask questions.